Continuing to solve equations now, we're going to look at a mixture of situations with three operations, fractions, negatives and indices. Because by this stage, you should be starting to feel fairly confident on a range of these skills. But let's start by doing a little bit on fractions. So, 3x equals 7. One operation, 2 divided by 3. Now, I could work out how many 3's go into 7, or I can just write 7 divided by 3 and leave it as a fraction. You might think this is being lazy, but actually it's efficient. And working out that 3's into 7 goes 2.3 recurring times is not valuable time. You might think writing x equals 2 1/3 is valuable. Well, it might be, but if the question doesn't ask for that, it's not essential. It's a skill you may wish to practice, but beware. So, let's extend that to a 3 operation situation. Okay, we've got a couple of new things here. We've got indices and a multiplier here. And I've done it under fractions, so you're suspicious that somewhere in this question, there might be a fraction in the answer. So, I've got indices, multiplication, and addition. So let's subtract first and subtract 5. Can you see where this is going? Let's divide by 3. If I've got 3/4 and I divide it by 3, I get 1/4. Here's a whole one, cut into quarters. Here's 3/4. If I divide that into 3 equal bits, it's quarter, quarter, and quarter. If you want to see that done differently, multiply by the reciprocal. Cross cancel the 1's, and then you'll get 1/4. Okay, so x squared equals 1/4. Now we learnt in the last video that x squared was a bit of a special case, and that's why I've used it again. So, it's going to be plus or minus something. So, something times by itself again makes 1/4. So it's going to be a fraction. Now if the numerator's 1, the chances are both the numerators are 1. And they have to be the same. So what number has to go here that's the same to make 4? Good. So x equals plus or minus 1/2. A couple of things in here that I'm going to go over one more time. First, if x squared equals, let's say 64, x will be plus or minus something. Now to get 64 you need 8 times 8. The second thing to go over is the situation like this. There are two operations here, and as long as I follow my reversing of BIDMAS, I'll get them in the right order. That is, I will divide first, and then I will deal with the indices. Okay. Let's look at one more situation slightly similar and see if we can resolve it. At this stage we're already getting to the point where we can do an awful lot with our skills. Okay. Three operations, all tightly packed together. How are we going to resolve this? First off, that 3 outside the bracket we know we can deal with first. So does 3 go into 48? If you need to, write your 3 times tables out. I would start at 30. Aha, it does. 10, 11, 12, 13, 14, 15, 16. Now look carefully. The squared is on the outside of the bracket, and then inside is the dividing by 2. So which order were these done in? Well, it looks to me like someone divided by 2 and then squared. So I'm going to have to deal with the squared next. So something squared equals 16. You might think 4 straight away. And remember, when it's squared, it's plus or minus. So that leaves me x over 2 equals plus or minus 4. Okay, so x is going to be whatever happens then when I deal with this divided by 2, which is multiplying by 2. So x is plus or minus 8. Now, there are a few more tricky negative situations we're going to address in the next video. And in the video after that, we're going to deal with assorted stuff to do with algebraic fractions. But so far, you've got a good idea of three operation equations and how to resolve those. You're unlikely to get an equation like this. You're far more likely to get an equation which is of the form seen in part 3. But it's good to understand that the rule still applies even as the situation gets more complicated.